This is Dr.D Govardhan, Professor Emeritus, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are discussing the problems on frictional force. Here, what is the friction? Friction is the force which always offer resistance to the body when it tends to move or when it is in a motion. Or in another words, it always acts tangential to the surface contact, but in opposite directions in which the body tends to move or moving. Ultimate frictional force. The ultimate frictional force is the maximum frictional force that is experienced between the contact surfaces when they are moving relatively one another. The maximum friction force that exists when the body is about to move. Here we are considering limiting friction only. Here I am taking one problem now. A body resting on a rough horizontal plane required a pull of 180 newtons, inclined at 30 degrees to the plane just to move it. It is found to a push of 220 newtons, inclined at 30 degrees to the plane just to move the body. Determine the weight of the body and the coefficient of friction. So the given data in the problem is the amount of force required to pull the body is given 180 newtons. For pushing 220 newtons. In both the cases, the forces are inclined at an angle of 30 degrees with the horizontal. W is representing as the weight of the body, and mu is representing coefficient of friction. N is the normal reactions that exist in between the contact surfaces. Now, first to consider the body when it is 180 newtons acting on it. Okay, according to this figure, the body tends to move toward the right side. Hence, the friction forces exist between the contact surfaces tangentially in opposite directions. Hence, it is represented in the figure as F1, that is acting in opposite direction in which the body tends to move. The normal reactions is always acts perpendicular to the contact surfaces, and here, according to this figure, here it is represented as N1 acting in upward directions. Since the weight is acting in downward directions, which is represented here as W now. And the force of 180 newtons is acting. It is having the nature of pull, that is acting toward the right side with the inclination of 30 degrees to the horizontal. Hence, we are resolving all the forces parallel to the plane as well as the perpendicular to the plane to analyze the forces which are acting on it. This 180 newtons is when it is resolved into horizontal force, the component becomes 180 cos 30 degrees, which is shown here the figure now. Similarly, the sin 30 is given 180 sin 30, it is a perpendicular force now. Since the body is about to move, means all the forces are acting on the body and in equilibrium position. So the equilibrium position, these forces are treated as here concurrent. That is, the line of action of forces are passing through single point. Hence, for equilibrium conditions, only two equations are required. They are the sum of the component of forces along the x direction should be equal to 0, and the sum of the component of forces along the y direction should be 0. Here, when we are taking algebraic sum means the forces which are acting toward the left side are treated as positive. Sorry, the forces which are acting toward the left side are treated as negative and right side treated as positive. Similarly, the forces which are acting in upward direction treated as positive and downward direction treated as a negative. Now, resolve the forces horizontally. Horizontal only two forces are acting. One is 180 cos 30, that is the component of full force, and another one is frictional force which is acting toward the left side. Hence, according to the problem, since it is the equilibrium position means the sum of the forces acting toward the left side should be equal to toward the right side. Hence, F1 is equal to 180 cos 30 degrees. From this equation, we got 155.9 degrees now. And resolve the forces vertically. The N1 is acting upward direction positive. 180 sin 30 degrees is acting upward direction positive. W is acting downward direction. Hence, we are having N1 is equal to W minus of 180 sin 30 degrees. From this relation, we got W 180 into sin 30 is equal to 0.5. We got W minus 90 newtons, which is shown in here figure and represented as the equation number 1 now. The frictional force is equal to given by F1 is equal to, according to the previous calculation, we got 155.9. But F is equal to, we are having mu N1, which is taken as mu. N1 is equal to, we got W minus 91, which is represented in the equation 1. From this, we got, this is the equation number here represented now. Now, consider push of 220 newtons acting on the body. Assume F to be the frictional force that acts because the body is now pushing nothing but it is the body that tends to move toward the left side according to the figure now. And the frictional force acts in opposite direction in which the body tends to move. Hence, it is represented here now. Ft is the frictional force. W is the remains constant for both the cases. It is acting downward direction and represented as W. And N2 is the normal reactions, which is perpendicular plane, is represented as the N2. And the pulling force is given now 220 newtons, which is acting at an angle of 30 degrees to the horizontal. When it is resolved into two components, the horizontal component is 200 cos 30 and the vertical component is given 200 sin 30 degrees. Now, resolving the forces horizontally, we have now F2 is equal to 220 cos 30. From this equation, we got 190.5 newtons. Similarly, when the forces are resolved vertically, the vertical forces N2 is their upward direction is positive, W is acting downward direction is negative, and 200 sin 30 again acting downward direction is negative. From this relationship we got now, N2 is equal to W plus 220 sin 30, which is equal to W plus 110 degrees, since sin 30 is equal to 0.5 now. Now, frictional force is equal to mu N2. From this relation, we got mu into W plus 110, which is shown in figure 2 now. From equation number 1 and 2, we got one is 155.9 divided equal to mu into W minus 990. In second case, we got 190.5 is equal to mu into W plus 110. Since the coefficient of friction is the remains constant for both the cases, hence we got on equating these two equations or just dividing equation number 1 by 2, we got 155.9 divided by 190.5 is equal to mu into W minus 90 divided by mu into W plus 110. Since mu is a constant on both sides there now, denominator and numerator, the remaining values now becomes W minus 90 divided by W plus 110. On cross multiplication, we got 150.9 into W plus 17,149 equal to 190.5 W minus of 17,145. So from this relations, we got on simplifications now. W is equal to 34,000 divided by 34,294 divided by 34.6, which is equal to 991.2 newtons. This is given here now. Substitute the values of W in the equation number 1 here now. That is the equation number 1 is 559. It is equal to mu into W minus 90. And substituting the W value 991.2 newtons, we got mu is equal to 0.173 now. Okay, this is our required answer. In second case now, two blocks A and B of weights 1 kilonewtons and 2 kilonewtons respectively are in equilibrium position as shown in figure. If the coefficient of friction between the two blocks as well as the block B and the floor is 0.3. Find the force P required to move the block B now. So in this figure now, the block B there, just over it one more block is there A. Now it is now applied a rope to the wall now to prevent its motions now, which is making an angle of 30 degrees with the horizontal. Now the requirement is find the force P required to move the block B now. Now the given data is the weight of the block is given. First block 1 kilonewtons, that is the upper block according to this figure. The second block B is given 2 kilonewtons. According to the figure, it is represented as B, that is below block now. The coefficient of friction which exists between all contact surfaces is given 0.3. The forces acting on two blocks A and B are shown in figure A and B respectively by drawing free body diagram. So I am taking here this block 1 now. This is representing, that is A according to this figure. The weight is acting in downward directions, which is represented as 1 kilonewton. The normal reactions offered by the surface is represented as N1, upward directions. When the force P is applied, this is toward the left side. Since the upper block is preventing, we are now taking the free body diagram of block A, not block B. Hence, the friction force which exists between A and B, that is with respect to the A, B and A is given by, since A is now, the B is moving, the A is preventing its motion now. Here the friction force is acting because the rope is now, it is acting toward the right side. That is nothing but it tends to move the body toward the right side. Hence the friction force existing toward the left side, which is shown in figure now. That is with respect to the block A, the friction force is acting toward the left side. N1 is acting upward direction. The weight is acting downward direction, which is represented as 1 kilonewtons. And the tension within the rope is always acts in opposite directions with respect to the object which is considered here now. That is the T, making an angle of 30 degrees as shown in figure now. Now resolve the forces vertically. The vertical forces is there N1, upward directions, 1 kilonewtons, weight, downward directions. When we resolve the component of tension, it is having two components, horizontal and vertical. The vertical component is acting upward directions, which is given by T sin 30, where T is representing tension in the rope now. So from these relations, N1 plus T sin 30 is equal to 1 kilonewtons. From this relation, we got T sin 30 is equal to 1 minus N1, which is represented in the equation number 1 now. And resolve the forces horizontally. F1 is acting toward the left side, treated as negative. T cos 30 toward the right side positive. Since the body is in equilibrium position, the sum of the forces which are acting toward the left side should be equal to sum of the component of forces which are acting toward the right side. Hence, T cos 30 is equal to F1. F1 is equal to mu N1, which is equal to coefficient of friction is given 0.3. Hence, it now becomes 0.3 N1, which is shown in figure, which is shown in equation number 2 now. Now, divide equation number 1 by 2, we got it now. T sin 30 divided by T cos 30, which is equal to 1 minus N1 divided by 0.3 N1. From this relations, T get cancelled, which is represented here color now. These two get cancelled. The remaining is sin 30 divided by cos 30 is equal to tan 30, which is equal to 1 minus N1 divided by 0.3. Hence, which is equal to now, which is equal to tan 30 is equal to how much value? 0.5774, which is represented, which is equal to 1 minus N1 divided by 0.3 N1. On simplification, we got to N1 into 0.5774 is equal to 0.173 N1, which is equal to 1 minus N1, or 1.173 N1 is equal to 1. From this relation, we got N1 is equal to 0.85 kilonewtons. But the frictional force is equal to mu into N1 now. Mu is equal to 0.3 is given, N1 is equal to 0.85. Hence, the total values now becomes 0.225 now. That is, this is the frictional force which exists between the block A and B now. Now, consider the block B now. That is the bottom block now. Okay, in this case, the weight of the body now becomes the total weight of the two blocks, W1 plus W2, which is equal to 2 kilonewton plus 1 kilonewtons, that is totally 3 kilonewtons is given now. And N2 is acting in upward directions now. And a piece of force is there now. And since the body tends to slide toward the left side, the friction force which exists in between F2 is equal to toward the right side. Similarly, the upper block always prevent the motion of the lower block. Hence, the friction force which exists in between the two blocks again, it is toward the right side only. Or in other words, the friction force F1 and F2 acts toward the right side. Applied force toward the left side. It is given now. And equating the forces vertically, we got to N2 is equal to, totally we got to 2 plus N1 now, because 2 kilonewton weight, N1 is there now, it is acting now. According to the previous problem, N1 is equal to how much it is now? 0.85 kilonewtons. So, which is equal to the total load now becomes 2 plus 0.85 equal to 2.85. This is the kilonewtons. This is the treated as the N2 values now. F2 is equal to mu into N2, which is equal to 0.855 newtons. Now resolve the forces horizontally. The P is equal to, that is the left hand force is equal to the sum of the forces which are toward the right side, which is equal to F1 plus F2. On doing the calculations, F1 is equal to, already we got to 0.255 plus F2 is equal to 0.855. The total sum now becomes 1.11 kilo newtons answer. Okay, effect of a friction in connected bodies. When the two blocks are connected together now, the tension in the rope becomes in equilibrium. But when you are considering free body diagram of block, assume 1, here represented here now, assume the tension in the rope, when you are considering individually, the tension in the rope, it acts toward the right side along the rope, that is the away from it now. Again, similarly, when we are considering free body diagram of second, the tension in the rope again acts away from it, that is towards the left side. Hence, the resultant tension within the rope now becomes the 0. when you are considering two objects together now. Now in this case, we are now first drawing the free body diagram of block 1 as well as the block 2 individually and representing the forces along the x direction and y directions. Since the body is in equilibrium position, by applying equilibrium equations, that is the sum of the forces which are acting along the plane should be equal to 0 and perpendicular plane also equal to 0. Just by using these two equations, we can determine the unknown quantities. This is a summary of calculations in connected bodies. Okay, now I'm taking one problem now. A cord connects two bodies of weights 300 and 800 newtons. The two bodies are placed on the inclined plane and the cord is parallel to the inclined plane. The coefficient of friction for the weights 400 Newton is 0.15 and 800 Newton is 0.4 now. Determine the inclination of the plane to the horizontal and the tension in the cord when the motion is about to take place and down the inclined plane. The body weighing 400 Newton is below the body weighing 800 Newtons. Okay, now I am representing now free body diagram of individual objects now. The given data is the weight of the first body is represented as W1, which is equal to 400 Newtons. The weight of the second body is represented as W2, it is equal to 800 Newtons. Coefficient of friction for the first body and inclined plane is represented as mu1, which is equal to 0.15. The coefficient of friction for the second body and the inclined plane 0.4. Let alpha be the inclination of the plane with the horizontal, T is the tension in the rope or the cord. It remains constant for the two bodies. Maybe the directions may be different. It depends upon the object chosen for drawing free body diagram. N1 is representing as a normal reaction for the first body. N2 is the normal reaction for the second body. F1 is representing the friction force between the first body and the plane, and F2 is representing the friction between the second body and the inclined plane. But F1 is equal to, we can write it as mu1 N1 and F2 is equal to mu N2 and so on. Now I am drawing free body diagram for the first body. Since the body tends to move downward directions, hence the friction force acts in upward directions, and the remaining forces are shown here in the figure as here N1 is representing normal reaction which is a perpendicular plane, and F1 is representing the friction force which is acting toward the right side because the body tends to slides in downward directions. The weight is always perpendicular to the ground, but when it is resolved into components along the plane and perpendicular plane, the along the plane now becomes W sin alpha and the perpendicular plane is represented as W1 cos alpha. This W1 sin alpha, it is always tends to slide the body in downward directions. These are shown in a figure now. Now, when we consider the body in equilibrium position and taking the forces which are acting along the plane, since the body is in equilibrium position, the algebraic sum of the component of forces along the plane that should be equal to 0, or in other words, sum of the forces which are acting toward the left side should be equal to the toward the right side. Okay, according to this problem, so F1 is acting toward the right side path and T is also acting toward the right side. Only left side is W1 sin alpha. Hence, W1 is nothing but it is given 400. Hence, 400 sin alpha should be equal to T plus F1, which is equal to T plus F1 is equal to mu1 N1, which is equal to T, mu is equal to 0.15 is given plus 0.15 N1 It is shown in figure equation 1 now. Similarly, resolve the forces normal to the plane now. The forces N2 is acting upward directions and W1 cos alpha is acting downward directions. Hence, 400 cos alpha should be equal to N1. Substituting the values of N1 in equation number 1 into, we got 400 sin alpha is equal to T plus 0.15 400 cos alpha, or by using this equation we got to T plus 60 cos alpha. Therefore, T is equal to, we got 400 sin alpha minus 60 cos alpha. The forces acting on the second body. In second body, WT is given 800 newtons, acting downward directions, perpendicular ground. Hence, when we have resolved these forces into two components along the plane or perpendicular plane, W2 sin alpha is acting downward directions, so W2 cos alpha is perpendicular to the plane. Similarly, the tension is always away from the object. According to this figure, it is acting toward the left side. Frictional force is, since the body tends to slide downward direction, it is acting toward the right side. N2 is the normal reactions. So, resolve the forces along the plane now. That is, the sum of the component of forces which are acting toward the right side should be equal to the toward left side, which is equal to 800 sin alpha toward the left side, T also toward the left side. It should be equal to F2, that is mu2 N2, or mu2 is equal to 0.40 N2, which is shown in equation 3rd now. Similarly, resolve the forces normal to the plane. Only two forces are acting now. N2 is acting upward directions and W2 cos alpha in downward directions. Hence, N2 is equal to 800 into cos alpha. Substituting N2 in equation number 3, we got to 800 sin alpha plus T is equal to 0.40, 800 cos alpha, which is equal to 320 cos alpha. Now, by using these two equations now, we got it now. T is equal to 320 cos alpha minus 800 sin alpha. This equation, the values for the T, which are given in equation number 2nd and 4th, we got 400 sin alpha minus 60 cos alpha is equal to 320 cos alpha minus 800 sin alpha. On simplification, we got tan alpha is equal to 0.3166. Alpha is equal to tan inverse of 0.3166, which is equal to 17 degrees 34 minutes. Substituting the values of alpha in equation number 2nd or 4th, we got T is equal to, now in the second, we got T is equal to 400 sin 1756 degrees. On simplifications, we got T is equal to 63.48 newtons. These are the required answers. Similarly, taking one more problem now, referring to the figure number 4, it is given here now. 4. Determine the least value of the force P to cause the motion to impede the motion toward the right side. Assume the coefficient of friction under the blocks to be 0.2 and a pulley to be frictionless. Here, according to the figure, the plane is inclined at an angle of 60 degrees as shown in figure, on which 150 newtons of body is resting now. It is connected to 100 newtons over the pulley which is having frictionless. That means the tensions on both sides should be equal now. This is useful for us for drawing the free body diagram. Now, we are drawing a free body diagram for the two bodies separately to determine the least force that is required to move these two bodies 150 newtons, 100 newtons toward the right side. The given data is the coefficient of friction between the bodies and contact surfaces. It may be inclined as well as horizontal. It is given 0.2. Motion of the block of weight 100 Newton is toward the right side and 150 also toward the right side is given. Now consider the equilibrium of the block W1 150 Newtons, which is making an angle of how much? 60 degrees is given. The problem. Let T be the tension in the rope. It is acting toward the right side. The weight is given. W1 is equal to 150 Newtons perpendicular ground. That can be resolved into two components now. Along the plane is represented as a W1 sin alpha. Perpendicular plane is a W1 cos alpha. Since the body tends to move in upward directions, the friction force acts in downward directions. Hence, F1 is represented as friction force. N1 is the normal reaction. This is the free body diagram of the block 1. Since the body is about to move, that means the body is equilibrium under the action of all these forces. Hence, we have to apply two equations which are used for equilibrium condition, that are the sum of the component of forces which are acting along the plane should be equal to 0. Similarly, perpendicular to the plane also equal to 0. So, when you are taking along the plane, T is acting right side, F1 is acting left side, W1 sin alpha is acting left side, hence T is equal to W1 sin 60 degrees plus mu1, or which is equal to W1 is equal to 150 Newtons into sin 60 plus 0.2 Newtons, which is shown in figure equation 1. Again, resolve the forces normal to the inclined plane. N1 acting upward directions and W1 cos alpha downward directions. Hence, N1 is equal to W1 cos alpha is equal to 60 degrees, which is equal to 75 Newtons. Substituting the value of N in equation number 1, we got T is equal to 150 sin 60 plus 0.2, N1 is equal to 75, which gives tension in the rope is equal to 144.9 Newtons. Now I am considering free body diagram for the second body, which is having weight is equal to 100 Newtons, that is acting in downward directions. And normal reactions is upward directions. The tension is toward the left side, which is given already we determined, which is equal to 144.9 Newtons. The friction force it is acting toward the left side because the body tends to move toward the right side. The P force is given, which is making an angle of theta. That is resolved into two components, P cos theta and P sin theta. Now all this under all the forces, the body is in equilibrium position. Hence, the algebraic sum of the forces which are acting along the plane should be equal to 0, and perpendicular plane is also equal to 0 now. By applying these equations, we got first one is resolve the forces along the plane is equal to horizontal T left side, friction force left side, that is T plus F is equal to P cos theta now. Since T is equal to 144.9, 0.2 into N, which is shown in figure equation number 3 now. Similarly, on resolve the forces normal to the plane, N upward directions, P sin theta upward directions, the weight is downward directions, hence N plus P sin theta is equal to 100 Newtons. From this relation we got N is equal to 100 minus P sin theta. Substituting the value of N in equation number 1, we got P cos theta equal to 144.9 plus 0.2 into 100 minus P sin theta. So P cos theta plus 0.2 P sin theta is equal to 164.9. So P of cos theta plus 0.2 sin theta equal to 164.9. From this relation we got to P is equal to 164.9 divided by cos theta plus 0.2 sin theta. It is represented in equation number 5 now. The minimum force, the force will be minimum required means the cos theta plus 0.2 sin theta, it should be minimum required now. That is, sorry, when just minimum force required means cos theta plus 0.2 sin theta should be maximum. That means cos theta plus 0.2 sin theta will be maximum if the differentiation with respect to theta should be equal to 0. So on differentiation, cos theta is equal to minus of sin theta plus 0.2 sin theta is equal to cos theta equal to 0. Or in other words, 0.2 cos theta is equal to sin theta, or tan theta is equal to 0.2. Theta is equal to tan inverse of 0.2, which is equal to 11.309 degrees. That means at an angle of 11.309 degrees, the force is acting, which is the minimum to move the entire system toward the right side. And substitute the values of P in equation number 5. The least force is equal to 164.9 divided by cos 11.309 plus 0.2 sin of 11.309. From this equation, we got to 161.88 newtons. This is the minimum force that is required at an angle of 11.309 degrees to move the bodies toward the right side, which are shown in figure.
Like, share and subscribe. Hit the bell icon for more updates.